Let's start solving question 4 in this video. So we have two functions, f of x, which is 3x squared minus 10x plus 16. This is a quadratic function because it has this quadratic term of x squared, and g of x, 8x minus 8, which is a linear function. Now we have to compute the area between the graphs of these functions on the interval of 0 to 5. So we have the functions over here. I plotted them graphically, which are not exactly accurate, not 100% accurate, but very close to it. And the reason I do it because it's wiser to understand this, what's happening on the graph, because when we calculate areas, we're going to work with the intervals, but we need to know what area we're solving. So f of x is the quadratic function. That's how it would look like. F of x would have an intercept, a y-intercept equals to 16, because when x equals to 0, f of x would equal to 16. So that would be the intercept over here. What else do we need to know? G of x has an intercept of minus 8, so g of x starts at minus 8. The slope is positive 8. And what's going to be the x-intercept? Well, let's see. 8x minus 8 equals to 0. That means that x is going to be equal to 1. So the x-intercept would be 1. Intercept over here would be equal to 1. Okay, now we're looking for the area between the graphs of these functions on the interval from 0 to 5. So when x is 0 and x is 5, meaning which areas are we looking for? Let's see over here. So we're looking for this area between the graphs. This is the area between f of x and g of x on this small interval, right, until here. After that, we have the area between them over here. And finally, we have the area between them on this interval over there. They're all between 0 until 5. Now the question is, what is that interval? Well, we have to define what are the points of intersections first, because we can see that the graphs intersect at 2 points. They intersect over here, so we want to find out that value, and they intersect over here as well. They intersect over here as well. Now, how can we find that? Well, we know the points of intersections are going to be where the functions are equal. So f of x equals to g of x. Let's make that. What's f of x? That's 3x squared minus 10x plus 16. And what's g of x? 8x minus 8. 8x minus 8. Let's take everything on one side to solve it. So we take 8x over there, we take minus 8 over there as well. So we will have 3x squared minus 10x minus 8x from the other side. It's minus 18x plus 16 plus 8 from the other side is plus 24 equals to 0. Now, to make it more simple to solve, let's divide both sides by 3. So we divide both sides by 3, and we have 3x squared divided by 3. That's x squared minus 18x divided by 3. That's 6x plus 24 divided by 3 is equal to 8. And 0 divided by 3 is just 0. Now, how can we solve this? Well, we can use our shortcut of quadratic equations. We put here x and x, and we're looking now for two numbers that when we multiply, we get 8, and when we add, we get minus 6. Well, if we use minus 2 and minus 4, minus 2 times minus 4 is equal to 8. Minus 2 plus minus 4 is equal to minus 6. So it works, meaning that this relationship is the same as the following. This equation is equal to x minus 2 times x minus 4 equals to 0, meaning that the points of intersection happen when x minus 2 is 0 or when x minus 4 is 0. In other words, this happens when x equals to 2 or x equals to 4. X equals 2 or x equals 4. In other words, we found these points over here. We found these points over here. This is one point of intersection, x equals 2. This is the other one, x equals to 4. Now, how can we calculate the areas? Well, we will have areas between the graphs of the functions, meaning we're going to use integrals. So we have three pieces, so we have 3 integrals to solve. Now, how is that going to look like? Let's see. For the first interval, we have the area defined from 0 until 2, right? Between 0 and 2. So between 0 and 2. And what do we have here? F of x has greater value than g of x, right? The line, the green line, is above the blue line on this range, meaning we will subtract f of x minus g of x dx. Hope this makes sense. Now, we go to the second range. We go to the second range over here on this area. What do we have there? The blue line is above the green line. So we'll have to subtract g of x minus f of x. Where? Between 2 and 4. These are going to be our boundaries. So between 2 and 4, we subtract g of x minus f of x dx. And finally, we have one more. The area between 4 and 5. So between 4 and 5. And what do we have there? Well, over here, the green line, the f of x, is above the blue line, above g of x. So we will subtract f of x minus g of x dx. Now, with that said, let's do one more step in this video. In the next video, we're actually gonna solve. What is f of x minus g of x? Well, we calculated previously. We took g of x on the other side, and we found out that f of x minus g of x is equal to 3x squared minus 18x plus 24. So let's do that. We have the definite integral from 0 to 2 of the following: 3x squared minus 18x plus 24 dx. Now we go to the second range, we go over here, plus the integral between 2 and 4. What is gx minus f of x? Well, let's solve it over here. What's g of x minus f of x? Let's see. G of x minus f of x is equal to, that's 8x minus 8, so that's equal to 8x minus 8 minus f of x, which is 3x squared minus 10x plus 16. Now if you open the brackets, what do we get? We get the following. We have 8x minus 8 minus 3x squared, then minus 10x, that's plus 10x, minus 16, so minus 16. Now let's group the terms together. What do we have? We have minus 3x squared, 8x plus 10x, right? It's gonna be plus 18x, so plus 18x. Minus 8 minus 16 is minus 24. So we found our next relationship. So over here, what we will have is 3x squared, right? We will have minus 3x squared, I'm sorry, plus 18x minus 24 dx, and one more range. The last range, let me just go to it. The last range is again f of x minus g of x. So what we will have now, we will have plus the definite integral between 4 and 5, f of x minus g of x, we calculated previously, that's 3x squared minus 18x plus 24 dx. Now we stop here in this video. Let me just zoom out because we will need more space, and in the next video we start integrating and finding out the area.